Hopefully I'm back. Okay. So you got your whole networking session going on in the chat.
Yeah,
That was
welcome
great.
back, Kallie. It's better now. And yeah, we used up the time to on LinkedIn. So it was
Yes, nice, amazing. So thank you for staying with me, and I hope I can. First of all, I hope that my mic will work. I'll go back and I'll try to speed up things a little bit so that we have time to cover everything. Um, okay, so for this session, what I want actually to do is create a vision in your mind. I want you all to have a vision of all the theoretical stuff that we learn about the whole process, the whole training process, the whole pipeline. I want to have a concrete example of how to implement it, how to write the code, how to make everything play together. So, okay. So what I'll be using is I'm going to show you an example pipeline of everything, of the training pipeline, of the monitoring pipeline, and the serving service. And of course, um, metadata storage. I'll be using Flight for the training pipeline. Flight is like it's like Airflow, if you know it. It's a workflow platform that we can create different tasks that talk to each other and that all go in a certain order. I won't go into details of why it's good Flight, and also MFlow. You probably all know it very well. The platform of MLflow. It's for experiment tracking, for storing metadata, for storing our models, and let's see how we all implement it together. Okay, so this is what we're going to go through today. We're going to have a whole training pipeline, using Flight. We're going to have a model metadata with MLflow. We're going to store our metadata in MySQL. And we're going to save our actual model, our actual blobs in S3 using MLflow. And we're going to serve our models, our predictions using Flask. So we're going to see how we all implement it together. Okay, so this is our example. Our example is the diamonds dataset. I hope and I'm pretty sure you all know this dataset. It's diamonds and all of their features like price, like carat, their measurements, color, and the price. The price is our label. It's the target, it's what we're trying to predict in our case. So we can see that the price is numerical, carat is in float, cut, color, clarity, it's all categorical features, and everything else is numeric, float. So this is the data that we're handling right now. Okay, so I want to take a look at how we're going to implement this. So first of all, I hope that everything is up because I tried to restart my Docker environment because I'm going to use it, and probably that was overloading my computer. So maybe that has to do with it. So I hope that everything is still up. But what we're going to have today, we're going to have an MLflow environment up. Let's see how we're running this. A simple Docker compose file that saves everything in MySQL. We're going to have the MLflow server. We're going to have a reverse proxy with Nginx. So I already have everything up. Let's see that it is up. after everything we've been through. So we'll go to localhost. Today, our MLflow environment is up and running. Let's go back. So the next thing we're going to have an inference service. This is actually the Flask service that we're going to have. I have everything here in the same repo. Let's take a look at the server. Let's take a look at the different routes that we're going to have. We have a predict route that we're going to use to predict our data. We'll have an update model. This route our flight is going to use. Every time we retrain our model, we're going to use this route in order to serve the new model that we just trained. Trigger pipeline, we're going to see later on what we're going to do with this. And a health check. So first, let's see that we have everything running. Let's see that the health check response is working. It's not working, so it's probably not up. Okay, so I'm using a unicorn command to run our app, to run our service. And let's see now that it's working. Yes, the service is alive. Let's try to predict something. Let's see if it works. Okay, so no trained model was found because we haven't trained anything yet. So let's go back. So that's what we have. We have our inference service. And the next thing we're going to have is our flight environment that is running on Kubernetes. It's running on my local host. Let's see that we have that running up. It's not running, but that's okay. I'll just start to run it up right now. It's going to take a little while, but that's okay because we can go through the details of what we're going to see in the pipeline, and then we can see the concrete example of how it's implemented in the environment. Okay, so let's see the different components of the pipeline. So we're going to see this slide a lot. We're going to take a look at each step of the way, how it looks like physically, how it looks like concrete in our example. So first of all, we have the data extraction. What is this process? What is this task? This task is about taking the actual data that we're going to train our model with. Let's go back to the flight code that I have here, and I will run later on. So I have my basic pipeline. I have my my code that will run. So you can see here, I already have all my dependencies installed. I have my flight packages. Oh, sorry, by the way, about questions, I will try to answer everything at the end. I just want to go through everything in one flow. I'll answer everything in the end, I promise. All right, I can see it's already running. In the meanwhile, you can ask all of your questions and I will answer them at the end. So just taking a look at my pipeline, I see I have all my flight imports. I have all of my sklearn imports for my model training. I have my Superwise imports for my modeler monitoring. Sorry. And let's go all the way down to my code. This is the actual workflow. This is what we're going to run. You can see we have many steps in the way. For example, extract data, validate data, prepare, train. So we have each step returning something. So let's take a look at each phase. First of all, let's take a look at extract data. So here you can see I'm using the diamonds dataset. It's just an open source dataset that I'm going to download locally, and I'm going to use that. So what I'm doing here is I have a price threshold. This threshold is going to be using me. I wanna first send all of the cheapest diamonds that there are. I'm going to have a threshold of 10,000. We're going to see that in a little while. I want to first only send the cheapest diamonds there are, and later on I'm going to send all of the diamonds that exist in the world, because I want to see how does my model is acting on new data that it hasn't trained on before. So first of all, just to get a good sense of how this whole pipeline going to work, how it's going to look like, let's just comment everything that I have. Now I have only the extract data part. So let's run only that. The way that I'm running my my pipeline, you see we already have oh, we haven't seen that because I've just deployed my my flight service. So let's see that it's up now. Great. So we see that we have our service up. We have 0 workflows. We haven't deployed anything. So let's just try to deploy our first pipeline. Yes. So this, I'm using the flight package. I'm using an image that I built and pushed before this presentation that I've made. You can see that I'm sending the diamonds threshold of 10,000. So I want to only send the cheapest diamonds that there are. So let's try to run this. Let's wait for the response. By the way, yes, I can see your question. Yes, the code is all open source. I will have at the end all of the links. Everything will be sent to you tomorrow also. You can take a look at the code. You can take a look at the slide. And you can run it also. You have a whole guide of how to run it locally. And I really hope you do run everything. Okay, so it's taking a little while. But while we're waiting, let's see if we have anything new. No, it's still waiting. Okay, so while we're waiting, let's take a look at the other phases that we have to this whole process. Okay, so going back to our slide, that is the first part, the data extraction. Basically, the input, getting the input to our whole process. The second phase is going to be validating the data. I want to make sure that I have the right schema, that I have the right features that I've selected, that I have everything going on for me, and that the input is as I expect it to be. So let's take a look at the second task, that is validate data. Also, by the way, flight is strongly typed, which means that I have to give it the schema of everything that I'm inputting and outputting out of every task. So here we can take a look at the schema that I've created. So you can see that we have all of the features for the diamonds dataset. So we can take a look here and see that we're using it for our tasks in order to run, because that's what we expect. So the validate data phase. What is this phase? we're trying to select our only the features that we want to train on. We only have, and we only want the schema. We want to check that all the numeric features are actually numeric. We want to check that all the categorical exist, all the ID, the target, everything exists. So in this phase, I'm just trying to convert all the numeric features into actual numerical types. If it doesn't succeed, I want to throw in error. So there's a validation problem here. I'm also filling empty fields, and I'm selecting all of the features that I want for my model. Okay, so that's the data validation. The next phase we're going to have is the preparation of the data. That's what we're going to see now. So prepare the data. As you can see, it's a very simple phase. We just want to split our data into train and test data sets, and that's it. That's the whole process, and we're actually preparing the data to be trained. The next phase that we're going to have is the main course, the main event, our actual training of the model. So after we've gathered all of the data that we need, everything that we need to run, now we're ready to train. So as you can see, in this phase, again, I'm selecting all of my features, transforming them, I'm cleaning. I will not go into further details about this part because this is not our part as ML engineers, right? We're not supposed to touch all of these things. It's going to be the data scientist that will create the algorithm, that will create the parameters. But just for simplification, just for a simple example, I'm transforming my columns, I'm cleaning them, I'm filling empty fields here. And that's it. That's the whole pipeline of transforming my features. Then these are my parameters for the model. I've selected to run them in random forest regressor. I've set my parameters. And now I have the pipeline, and I can fit my model. So that's the actual training part. I'm running the whole process. I'm training my model. I have some metrics stored on the side, and so after I'm done with everything, after I'm done with training and have my score saved on the side, I wanna log all of my metrics to MLflow, right? Now that I have my my model trained, I wanna take a track of it. I wanna save it on the side. I wanna see later on when I'm using different version of my model, I wanna have a reference back to what I've trained, what are my metrics are in the past, what worked better, what worked worse. I want everything to keep track of. This part is for, as you can remember, my MLflow. I'm going to save the metadata, all of my metrics. I'm going to be saving them under MySQL. All of the blob storage, all of the blob objects, I'm going to be saving under S3. So that's going to be, for example, my pickle object and my scatter plot image. Everything is going to be saved under S3. Everything that is not tabular. Okay, so I'm done logging my parameters. I'm done logging my model, and I'm done with everything. So now it's time to take my model and pass it on to the next phase. So this job lib serialized file is just going to take my pipeline, my model pipeline, and it's going to pass it on to the next phase in this whole process. Also, I see that it's not really running. Let me just take a look at it, because it doesn't really make such a difference if we see it in front of our eyes. I just want to make sure that we can run it. So let's try to run everything now. Hopefully it'll finish in time. Okay, so where were we? We were at the part of training the model, right? So I've serialized my Python object, and I'm passing it on to the next phase. So let's take a look at what we have next. Oh, by the way, in this phase, you can see that I can control the resources that I'm using. I can control how many CPUs I'm going to be using, how much memory I'm going to use. And this is because it's pretty heavy, a heavy phase. So I want to be using more resources. I want to make sure that I have enough resources for this phase. Okay, so I'll just try to increase my resources in Docker, because that's probably why it's not running. But let's move on with the next part. Okay, so I'm finished with my training. I trained my model, but is it good enough? How can I check this, right? If we have a manual job, if I have, sorry, not a job, but if I'm a data scientist, then this whole process is very manual, right? I'm looking at the performance of my model. I'm trying to evaluate how good is it, but I want to have something automatic, something straightforward, something that will not be wrong. I want to have something concrete that will validate my model. So first of all, the evaluate model phase is for just a second. Let's just see that my flight environment is still running. Okay, it's not running. I'll just have it running back again. Okay, so this will try to run again in the background. So I'm trying to evaluate if my model is good enough for production, right? If it has better performance, if it's good enough for me. So every single time I'm going to have a static data set that is going to be it's going to be distributed pretty evenly. It's going to take a few edge cases in mind. It's going to have the most diverse data that we can try to get, and we're going to test every single time on this static data set if our model is good enough for production. So if, for example, we have our training model on our training set, then how can we know that it's not overfitted? How can we know how it will react when it see new data? How will it react when we see new features, not new features, but new different data, different values? So how can we know that we're not overfitted or underfitted? So we have this always stable data set that we're going to test on. It's most of the time called validation data set. So we're going to have our model try to predict on this data set. For this example, I've just taken the same data set the whole diamond data set. But we're trying to predict on it and see all of the metrics that we get out of these predictions. And of course, we're going to log everything because we want to track everything backwards and come back to it later on. We'll have the scatter plot. We want to see its performance. We can also log our scatter plot. And okay, this is used later for monitoring, so let's just try to ignore this. But we're returning our performance, all of our metrics. All right. So after we've evaluated our model, our trained model, we have all the metrics. We have how it acts related to the validation data set, the static validation data set. Now we want to actually decide, is this model going to deployment? Are we going to send this model to production? Can we trust it? Is it good enough? Is it going to cause trouble? So the next part is the actual decision making. Are we going to send this model to production? So first of all, we can log all of the metrics that we have. We can get all of the metrics for the old. No, sorry, we have all the metrics here, and now the actual decision making is starting to happen. Can we trust this model? Is the metrics good enough? This is a pretty static way to check this, but we want to have some concrete limit to where we decide our model is good enough or not. So we're going to send the run ID and also true that we do want to send it to production, and false if we don't have good enough performance in order to send this to production. So we can see that we have here the variable is to deploy. Just let's check one more time if we can send the whole pipeline to run through flight. Yeah, maybe it'll take a few minutes. But okay, so we have this decision. We have this decision. We've trained our model. We've evaluated it. We've checked every metric. Now we want to see, can we actually deploy it? If so, so this is a conditional in flight, what we have here. So this conditional is called is deployment. It's just a name. So if is deploy is true, I'm using actually is true here because all of the outputs of all the tasks are just a promise. It's called in flight. It's a promise. It's not an actual usable object that we can use here in the workflow. We can only use these promises inside of each task. So you can see also that the previous output is the next phase's input. And this works for every task that we have here. So is deploy is a promise, and in order to check if it's true or not, we have to use this function. So if it's true, then register to Superwise. We're going to see in a little while what this means. Else, interrupt the pipeline. That's it. We're going to throw everything to the trash. We don't want anything to do with this model. It's not good enough for us. We've made a decision and we want to stop this whole pipeline. So we don't want to deploy it. Let's see just a very basic, just raising an exception. I want this pipeline to stop right here, right now. So that's actually the next part that is interrupting this whole pipeline. That's what happens if the validation fails. But if it does, if it doesn't fail, if our model is good enough, if it passed all of our checks, all of our limits, then we can deploy it. So first of all, before we deploy it to the actual serving service, um, we'll have registering to our monitoring platform. So in this platform, in Superwise, as you remember where I work, it's we need to create a new model inside the platform, inside the system. So we first check if there's already a model with the same name that exists. If it does, let's just take its metadata, its ID. If it's not, let's create. Oh, sorry, it's the opposite. If it doesn't exist, let's create it. See, create. If it already exists, let's just take its ID. And moving forward, so we've created this model object in Superwise because we have a new model. But for the same model, we're going to have different versions, right? We're going to retrain our model. We're going to use different data set. We're going to use different algorithm maybe. But this model, this same problem is going to be saved. So this is why we use the model object for a certain problem. But if we want to create a new a version of this model, like we trained it again, we use a different data set, then we need to create a new version inside of Superwise. So how is this going to happen? First of all, we are taking our trained data set, the data set that we're using in order to train our model. Maybe it's going to be different every single time that we train our model, maybe not. But for this example, let's just create a data set every single time, a new data set. So we can see here that I'm creating a new one. It's of type train. Actually, it says here test. Let's change it back to train. And I'm using the file that I've just written using the data set. That's it. So I have it created. Now I can create a new version inside of Superwise, and I'm going to log my predictions into this new version. So every time I train my model, every time this pipeline runs, a new version is going to be created, and every time that that I will predict new values, I will be predicting them and logging them into this version that I've created in Superwise. So I'm activating this version because I created a new one. I want to be able to say that this is the newest version. This is the version that new predictions are going to be sent into. Okay, so that's it for Superwise. We've created a new model, we've created a new data set, and we've created a new version. So now everything is pretty set up for us to go to the next phase, right? We can go we could go here to the pipeline.
Sorry, Kelly. We're just
Yeah.
seeing the basic pipeline.py on your screen.
Yes.
Okay.
Yeah. Oh, why? What do you want to see it?
Was the presentation to be shown or this code file? Just wanted to make sure.
Yeah, I'm showing this code and also the presentation.
Okay. No worries. Yeah. You're not seeing any changes in the code. So, okay. Thank you.
Okay, so now that we're done, we've gone through every single process that we need in order to train our model. We've finished validating it. We finished registering to the model system. Now we're ready to actually deploy, update our service that a new model has been created. Oh, sorry, my phone is connected to my computer. So that's it. We want to deploy our model into the service, and we want to let the service know this is the newest model. This is the newest version. You can already serve this model, and you can receive predictions on this model. So let's see how it looks like. So this is a very basic step. We're just sending a request. We have our pickle object. Remember that we've already we've saved it under S3. So we have the whole path of the model, of the newest model. And now we're just sending a post request with the newest path, the newest model ID of Superwise and the version ID of Superwise. And that's it. That's it. That's where the pipeline ends. So we've updated our model. And okay, so I see the image is just not finishing, but I want to just show maybe how it's supposed to look like. So this is how it'll look like under flight. Okay, so we have the extract data, everything is going well. Here in the validate model phase, we're deciding whether to register to Superwise or interrupt the whole pipeline. After that, if we've succeeded, then we're deploying the model. That's it, that's the end. So this pipeline is going to run every single time. And our service, let's just connect the dots there. Our service is going to be updated. So we're updating our model. Now we're ready to serve this model. And then we're ready to take predictions. And inside of this prediction function, let's just take a look. So you can see we have our model that we've saved on the side. Right after we've updated our model, it's now ready to for predictions. So we can already predict things, the instances that we've sent, and after that, we need to send our metrics to Superwise our predictions. So we have the predictions, we have all of the values that we've sent. Now we want Superwise to have these values and detect if there's any drift, if there's anything that is wrong with the data, maybe missing values, maybe we can create many alerts on the data that if something drifted out of the normal. We can also see the importance of every feature. We can also see the distribution of every feature that we've saved. And so this is for Superwise. We're logging every time we're sending predictions. And let's go back. Okay, let's just see one more thing. Let's just see how the platform looks like and how we can connect this platform into our inference service and to the whole pipeline, because we want to have everything automated. Remember, we want to have everything working in one single orchestration that talks to each other. We want the service to talk to the monitoring platform, and then back to maybe retraining if we have any problem detected. So let's, for example, see how we can connect this platform to our services. So I've just got into the demo project and into policies, and I can create a new policy here. Let's just take an example. I can create my policy on some metric that I want. For example, quantity. If I have an abnormal amount of predictions sent in one day, maybe I want to be alerted on this metric. Maybe it's not good enough for me. So we can select here the direction of the anomaly, the sensitivity, but let's just keep everything by default right now. And for now, we can only aggregate the whole alert only on a whole day data. So let's just keep that. Segments. I can also segmentize my data, right? So if I have the diamonds data set, I can create segments out of different colors of the diamonds. I can create just different groups that I want to take a look at. So for example, if I have people data, right? So I have their country, their originated country. I can create a segment of all the countries that exist in Europe. So that's an example for a specific segment. But for now, I'm just gonna take the entire data, every single feature and every single value. I want to have it scan, for example, every day. And that's okay. So we got to the actual important part. How can we create a connection between this platform into what we've created until now, to the pipeline and to the service? So we can create a new integration using a webhook. Let's, for example, call it trigger pipeline. And I can put here my IP, just as an example, and use the trigger pipeline route. So let's take it back to our service. So as we've seen, we have another route that we haven't talked about, which is the trigger pipeline. So whenever we get a post request into this route, we're going to retrain our whole model. So we're going to run the pipeline once again and retrain. So okay, so that's it. So that's how everything connects to each other. So let's take a look at it one more time. Sorry. Okay. So we have the whole training pipeline that we've seen in flight, all of the different phases of training a model. We have the different metadata stores, the model registry. We have the inference service, and we have the monitoring service, and everything connects to each other, and everything works in one unified unit, and everything is running automatically, detects itself, and retrains our model. Okay, so just one quick note, because I want to have time answering all of your questions, but we've talked about having level 0. As you remember in the article of Google, we have level 0 of maturity in organizations. We have level 1, which is what we've seen here, right? That the whole training process is automated, but level 2 is making everything automated, right? Because in our example, we took a very static data set. We've taken the same model, we've taken the same algorithm, everything is pretty much the same, but we can automate everything. We can create Also a feature store that the data scientists will choose which features to create, and then maybe the whole data extraction part will be dynamic. Right, we can take every single data set that we want, every single feature in one dynamic way, and we can create a whole CI/CD process that whenever maybe a configuration store, whenever a configuration file is updated, we can trigger everything and we can take the whole configuration and run it on our pipeline. So we can basically make everything here dynamic. And so that is level 2. So what I want you to take away from here is how you can imagine that you can imagine how to expand this whole process to make it super dynamic, super automated, without no human touching everything in the process. And that is the vision of this whole presentation, basically, that I want you to live with. Okay, so thank you, everyone. Had a lovely time. And now I will answer all of your questions. I hope that I see them all. Because you've talked a lot in the beginning. You've had a whole networking session. Oh, just before I forget, I will paste all of the links and in the chat that you can use all of these links. You can take a look at the code that we have under GitHub. You will get a recording of everything, and please check it out and try to run it yourself, maybe, if you dare. Sorry, let's go back to, for those who put ML pipelines in prod, what are your biggest challenges? I think I will answer it. I hope it's a question for me, but I see that it's a previous question for still going in your networking session, but I will answer that. I think the biggest challenge for me is orchestrating the whole process with the data scientists. Right, they're different than software engineers. It's a whole different process, and it's a lot of psychological process more than a technological, maybe even process. So I think that's the biggest challenge. Okay. So there's a question about Flask, whether or not to use that in production. So that's a great question, because Flask is very not suitable for production, to serving models in production. That's not a very good technology for that, just because it's not efficient enough for predicting models. So I would recommend checking other technologies that are more suitable for this purpose. This was just for the example, so don't take it as a given. Are you using Docker because the models need more compute power than what is available on your laptop? So actually not, because the Docker is still running on my laptop. But I'm using Docker because that's a very easy way to deploy everything, to deploy the ML flow, deploy Flight. It's very native for these purposes. So it's just easy for me to deploy all of them at once in one single command. Okay, what are some alternatives to Flask that would be more suitable for production? That's a great question. I can't actually answer that because I don't have very much familiarity with them, but I would recommend looking into them. Just write serving services for machine learning. I'm sure there are a lot of examples. Okay, I see there's a question. What are the capabilities of Flight in the ETL process, especially from multiple sources? Can you please talk about that? Okay, so Flight is very good for machine learning processes. And why is that? So first of all, let's take a look actually at the example. It'll explain very good what I want to pass. So if you've ever seen Airflow code, it's very much similar to this code. See, we have tasks that talk to each other. We have a whole workflow that puts together the different tasks. But what we really have here that is different. So first of all, we've talked about that. It's the whole schema validation. So, for example, if I write I create another column, this won't work. This pipeline will not go through because it doesn't pass the schema validation. So that's very good, right? Because we can validate almost natively to this technology that the schema that we want is exactly the schema that we get. Another thing is also the caching mechanism that we have for each task. So we can choose which task can be cached right after we run it. So you can see here, for example, most of my tasks are cached. You can see here it's not cached. But that was just for the presentation. It doesn't mean a lot here. But you can also see that we have cache version. So for example, if we're training our model with different algorithm, but we have the same data set, the same training data set, we don't want to extract it all over again every single time, right? We wanna cache it. So we have the caching, but we also have the version. If we do suddenly want to create a new data set, we want to bring new data, so we can just increment this version and it'll make sure that this process runs again from the beginning. And very importantly is the resources control that we have here. We can make sure that our training phase gets enough resources, or that it doesn't overload the system, or that we don't use more than we need to. And that's because of the training phase is mostly the heavy lifting of this whole process. So most of the time we want to control it and we want to have this ability. So this is, in my opinion, why Flight is very, very good. So I see there are no more questions. I really hope there are no more questions, that I've gone through every single one of them. Okay, so that's it. Thank you, everyone, for joining this session. Thank you for also sticking with me during my technical problems that I had in the beginning. You were amazing. You will be sent tomorrow all of the information that you need, a recording of this session, further reading. And that's it. Thank you, everyone.